All right, everyone, welcome. Thank you for coming on Friday afternoon, as always. Really appreciate it. My name is Juan Wachs. I'm an assistant professor in civil engineering and also assistant director for ICON. And we really are excited to welcome all of you to our welcome event. Every year we have this kind of event just to welcome our newly affiliated faculty and also introduce ICON to every one of you about our program as well as our own degree, our master program, professional master program. Today we'll have 4 newly affiliated ICON faculty lightning talks from Professor Chen, Playa, Tanaka, and Professor Ye across 4 different departments. And after that, we'll have our very first ICON weekly seminar this semester by Professor Juan Wachs from IE. And also he will share his experience by serving as program director for NSF, National Science Foundation. And after that, we'll spend 30 minutes to mingle and take good photos. And with that, I'm gonna hand over to our ICON co-directors, Professor Xiaoshuai Mo and Professor Xue Sunway.
Good afternoon, everyone. My name is Xiaoshuai Mo. I'm a faculty at Purdue Aero and also co-direct ICON, represent Institute for Control Optimization Networks.
And very sure I still am professor in electrical computer engineering, also co-director of ICON. Welcome.
Yeah, welcome. Welcome to our first event. And today I mentioned, every year we have this tradition to welcome our faculty and new student and also introduce our newly affiliated ICON faculty. And first I would like to introduce to you what do we mean by ICON. ICON is actually a platform sharing and all the information and in research collaboration and teaching coordination and also external engagement in robotics autonomy. And actually the name ICON is naturally comes to represent control optimization and the networks. And this ICON was launched in 5 years ago. It actually with the great support of Dean Mount Chan that time and now President Mount Chan. And also with the many department head support, and now it's also, for example, Dimitri, and now is our senior vice president for online education. And we also got support from Arvind and Luna, and also Bill, GS, and Eckert, and really, thank all the leadership support. And also now we have 102 affiliated faculty members. We actually start from a group of faculty about only 25 faculties within college engineering across 5 or 6 departments. And now we have 102 faculties from about 16 departments across 5 colleges.
Yeah, and I think, when we started ICON, it was basically an effort to try and bring together all the faculty working on autonomous systems and controls. Many international universities may even have entire colleges of control or departments of control because it's such a broad discipline. Whereas here in the States, normally we have this under different departments, but clearly we're all interested in the same general themes. And so ICON was a community building effort to try and bring people together into this kind of a forum so that we could collaborate, exchange information, etc.
Yes, in the past 5 years, when we were launched and Dr. Mount Chan gave us 3 missions. Is research collaboration, educational coordination, and external engagement. And we have achieved a significant amount of progress in the past 5 years. For example, in research, we have nailed down several large projects, including a very recent ones with collaboration with the SAB, with the $30 million conference cost. And mainly we study multi-agent federal learning for situation awareness in battlefield. And also other like a mid-scale and small-scale growth. For faculties, especially newly affiliated faculties, and so please, if you found some fun information very interesting, and you are looking for collaboration, feel free to share, the information across ICON, especially through our ICON faculties list, and Xue and I will be happy to support this kind of coordination. And actually, each semester we also want to let our faculty know that. And either you want to, do some coordination for large proposal, funding proposal, or your class teaching, or serve each other's CISA committee, or develop some collaboration for faculty across the department, please go ahead, to check out the credit card and for lunch meeting, and ICON we will pay for that. And further know that there's one success story is from Dr. Yu Shi lab and Dr. Jian Jin lab, and they start meeting regularly and just nail down proposal from on this kind of robotics manipulator for agriculture.
Yeah, no, absolutely. I think that's our goal, right? To bring people together. So if you do, as faculty, want to go after something and you say, I don't know who the right team members are, could you help me form a team? That's what we're here for, to reach out.
Yes, and also for education we have weekly seminars, and Ziran mentioned actually Ziran, Yu Shi, and Yan Wu is our seminar organizer. We spend a lot of time and efforts in identify the right speaker, the right topics, and also we are trying to nail down like 11 or 12 seminars at the beginning of the semester. So for those especially graduate students, either PhD student or master student, I would encourage you to come to Icon seminar in this room and also this time, 3 o'clock, and every Friday. And remember this, if you already in Icon student email list, you will get the list of this seminar speakers. We got nailed down several from academia, including Harvard and other like peer universities, and also Google DeepMind and also Boston Dynamics. So please, come to attend the seminars.
Yeah, I think as graduate students, this is definitely one of the most important things, right? Being able to be exposed to the top researchers from around the world, the newest ideas that they're exploring, because when you graduate, yes, it's important that you know the stuff that you're working on, but it's also important that you have a broader context on different kinds of approaches to these problems, because you're likely going to be leaders in whatever field you end up going into, and you're going to be managing people. And those people are going to come to you and say, how do you think I should solve this problem? And you want to have an awareness of the kind of work that's being done to be able to direct them. The seminars are the best place to do that, right? You take your courses, definitely, but this gives you a broad sense of what's happening. So do attend.
Yes, and also for Icon, we also organize several activities with engagement with external, and also for faculties, and especially if you want to introduce new connections, especially from industry and from high tech, please email Shias and myself or our seminar organizer. We will try to coordinate a visit and inviting our your industry POCs. I know that some of you reach out to us and suggest some seminar speakers or even from industry people visit. We will try our best to support, and also when we have the support from industry, we will try to we'll let everybody knows, and including our Icon faculty and students, and feel free to join the Icon's events.
Yeah, absolutely. I don't think I have anything else to add to that.
Thank you.
One other announcement, which maybe people who are on the list now maybe didn't get, but one thing that Icon has done in the past year has we've had the opportunity to sponsor many outstanding student teams, in particular record-breaking teams. So we had the world record for the fastest Rubik's Cube, which meant how many people saw that go around, probably on videos and people.com and everything, right? So Icon was proud to be able to co-sponsor that. Icon co-sponsored the recent activity by the Purdue AI racing team, where a team came in second internationally in the competition. So if you have a student team or even a faculty team that's going after some really high-profile record-breaking or competition-winning initiative, reach out to us, because we have a program that can potentially sponsor either travel costs or material costs, etc. Okay, so if you do have something like that, we highly encourage it, right? Because it's high impact, high visibility, and we're here for that kind of stuff.
Yeah, and also I believe we just submitted the project-based learning that course number and for approval. That for master student in robotics, autonomy, and IoT. And we also encourage you, if you want to form a team to run for the competitions, and for example, robotic conference ICRA or AROS or other control conference like ACC or CDC, please feel free to form a team and look for someone faculty advisor, and Shias and I will also could help you to identify faculty advisor, and you guys could run for the competition. This is also counted as your professional skill development. Is to be finalized.
Now I'm done.
Yeah, thank you.
As most of you notice, here we have 4 names here. Besides Shaoshai, Shias, myself, we also have Professor Philip Perret, who is actually in charge of our student activities. So he might spend a few minutes to talk about our student conference that we are organizing every year.
So last year we had Sibi and Antonio, I don't know if Antonio was here. They were general chairs and they were awesome and led a great conference in the spring. This year, we're going to have again our Vital and Josh here, like one second. But they sent emails to try and recruit people, so I think they were gonna close that survey by the end of this week. So if you're interested in, you're a student, you're interested in being involved, it's a great way to learn, great way to meet people, great way to build, again, professional development skills. One other thing, we're also hosting the Midwest Workshop on Controlling Game Theory at the end of next semester, or towards the end in April, I think. Shoot, I should have the dates. They're in my calendar. I can send an email reminding people. I think I sent an email a bit ago, but I'll remind you guys exactly the dates. But yes, people will come here. It'll be great. You should participate or at least attend. It's a great opportunity to bring everybody from around the Midwest at least. And if you have, again, ideas on who you want to invite, I'm in charge, so we can do whatever we want. So, as long as Tim is okay with it. But yeah, so exciting, it's gonna be a great year and happy to chat with, and if you have any other ideas for stuff other than student conference that you wanna do, we can, again, we have funds, so we're all about enabling students, so if you guys wanna do stuff, we can make it happen. Nira.
Yeah, if I could add something to that, one of the things that we wanted, really encourage students to do is to use the icon students list to do things like advertise your defense. Right, when your defense is coming up, that's a great thing for your colleagues in this room, whether faculty, might want to attend. For faculty, it's great. We often do like to learn about what our colleagues are doing, by attending a PhD student's defense. It's a great way to do it. I think folks are really hesitant to hit send out an email to that big list. But that's exactly what that's for. So please, advertise PhD defenses or other events that you think your student colleagues and also the faculty that have.
And they are filtered, so if you do a really bad job with email, like hopefully Shashway and Trace won't send them out. Yeah, awesome. All right, thanks, everybody.
All right, thank you, Phil and Nira, for the comments. So now I'm gonna turn it over to our professional master program contact, Eric and Jerry, to introduce our own professional master program by ICON.
Thank you, Bob. Edward's gonna lead it off. for us.
Yeah, hi folks. Welcome everybody, whether you are continuing or whether you've just arrived on campus. I'm sure it's been a dynamic experience over these first couple of weeks. And hopefully for those of you that are continuing your programs, it feels really like you're back home. My name is Eric Vandenvoorde, and I have the pleasure of leading our Office of Professional Education in the College of Engineering, focusing primarily on industry-oriented professional master's programs. But of course, my message and welcome today is for all of you. Lead into ICON. This can really be the accelerator of your entire experience, whether you're focusing on research and your thesis, your doctorate, whether you are focusing on building a career for industry. It's really special to have 100+ faculty that want to partner with you in industry-connected projects and in research. It's really special to have this kind of community, right? So really lean into it, take advantage of it, and be a proactive, not only somebody that benefits from ICON, but contributes to it. You know, this experience will be what you make of it. And so really be purposeful and intentional about, you know, having this be a memorable experience that helps you achieve your goals, you know, helps advance Purdue's reputation, and really allows you to connect with human beings, right? Because I think that's one of the best parts of ICON is human-centric technology projects, right? And I think that's something to be valued. Ultimately, what is an organization? You know, what is an institution? What is a country? What is our globe? It's all of us together, right? So let's really make that the centerpiece of this experience and do wonderful things with technology as part of that. Just really want to thank Dr. Mo, Dr. Sundaram, Dr. Wang. All right, it's a pleasure to be on these projects with you all, and feel very blessed for that. I'll turn things over to my wonderful teammate and colleague, Jerry Janecko, to talk with you a little bit about what you can expect from our team in terms of professional development and student support.
Sure. Thanks, Eric. I appreciate it. So my second go around with this welcoming, and I'm even more excited than last year. big things have happened with our 3 ACS programs, autonomy, IoT, and robotics. I'm going to give you brief bullet points here, but first of all, I just want to thank Dr. Mo, Dr. Sun, Dr. Wang, Dr. Prey. Thank you so much for your support. I appreciate it. It sounds like you have a lot of money over there, so I'm going to
There, buddy.
And then just a brief shout out to the faculty, you know, on a quick turnaround, they were able to, part of our orientation on board is have us visit their labs with Dr. Mo, Dr. Wang, Dr. Yushi, Dr. Yanggu, Dr. Rondai, Professor Wachs, and Dr. Kirshner. Those are the 7 that we had, and I appreciate that, doing that on such a turnaround, make themselves or their students available. So it was a great experience for everybody that was involved. So ACS, these are 3 degrees. I'm so excited to see so many of our students here. Just to show hands, if you're part of the ACS program, can you raise your hand real quick, please? Everybody, come on, everybody, we got a bunch here. Okay, this is great. I love it. Both cohorts too, both returning and new students. So as Eric said, it's probably been a whirlwind for the new students. And whereas Udi's here, a couple here returning students. It's going to get better, right, Udi? It'll be calmed down a little bit. Okay, good. I'm sure everything's racing. So we have 36 new incoming students. As of today, we have a number that wanted to be here in August but cannot get here. So we're going to see at least 6 more in January just for deferrals, which means we're going to have even more applicants. I looked at this morning. We have 36 applications for January, so we're going to go through those pretty quick. So we'll have a decent class for January. We have 76 total students. We had 2 graduates actually with this first academic year, which was a surprise. We didn't expect somebody to go through it in 1 year, but we had 2 that had a great job offer, a full-time job offer, looking for an internship, and he ended up was able to finish quickly. So that's something that we're very proud of. That 2 graduates. Next year we'll have many more graduates, and these numbers will increase. Just to give a broad overview of how, we call this an interdisciplinary degree, but it's interdisciplinary in many different aspects, or diverse in many different aspects. First and foremost, degrees awarded across 12 different countries throughout the world. The students in our program, there's 13 countries of citizenship represented. We have 17 unique fields of study. This is the really interesting part. So we have 17 different unique degrees of our 76 total students. So that really shows you the wide breadth of talent and sort of interdisciplinary nature that this offers to that are attracted to these degrees. We had our first a number of students engage in co-ops and internships. We had 18 companies that had hired on our students in that respect. Tesla, Applied Food Dynamics, Dexterity, a number of top companies that our students are at, and some of them are even there this fall. So not all 76 are here. Some are still doing co-ops this fall. We had our first Fulbright student to come into the program. We hope this is the first of many more, which is fantastic. And then the faculty that are in the room and those that are with ICON, this is the biggest, I would say one of the biggest drivers of this program is this project course. It's so valuable. Students, once they find out about it, they really want the interdisciplinary nature, and this project course are 2 main factors that brings our students applying to our program. And so we had 39 project course offerings last spring. We didn't do anything in the fall just because we wanted to get our feet around us and just get know what we have in front of us. And then we had 39 offered in spring. 26 students were enrolled. That number has already increased, and we will see those numbers go up thoroughly. So it's an exciting time to be not only part of ICON, but these 3 degrees. If you're a student outside of these, please network with these students. They're very talented, and vice versa. We push for you guys to be here, ACS students. Network with all of the people in this room, both other graduate students, whether it be master's or PhD, as well as the faculty. This is the reason why you're here at Purdue. This is this intersection of the different minds, the different interdisciplinary nature is why we're here. And I want to thank all of you again. So thanks for your time. I appreciate it.
Thank you, Eric. Thank you, Jerry. Now we'll turn the stage to our newly affiliated ICON faculty members, Professor Chen, Professor Playa, Professor Tanaka, and Professor Ye. Let's go one by one. Professor Chen, want to get started? Yep. Feel free to ask any questions after each of the presentation.
Hello, everyone. Very nice to be here. So my name is Wei Chen. I did my PhD at Georgia Tech, postdoc at Caltech, and then previously I did my Bachelor of Science at Zhejiang University, China. So if I want to summarize my research in one sentence, that would be to develop a foundational understanding on reinforcement learning and also learning in game algorithms with through the lens of stochastic approximation. So let me start with the motivation. So reinforcement learning has exploded in the last probably decade. So it starts around 2015 when DeepMind developed this AlphaGo, a superhuman AI Go player that beats the best human player in the world. And then the most recent probably large event in reinforcement learning is the development of reinforcement learning with human feedback that was used in all these large language models. But if you think about real world applications such as, let's say, power systems, scheduling and queuing systems, and also autonomous driving and many others, in these large scale safety critical systems, reinforcement learning actually faces many challenges. So you don't hear, let's say, real successful stories of reinforcement learning in these applications. So that kind of motivates my research. I want to develop theoretical foundations of reinforcement learning that kind of guarantee practical success of reinforcement learning in all these applications. So next, I'm going to start with reinforcement learning 101. So MDP and reinforcement learning. So MDP stands for Markov decision process. So if you're familiar with Markov chain, then you know, like in the Markov chain, there's states and then there's transition probabilities. You just observe the Markov chain evolve. So MDP actually has two more ingredients here. One is that you can actually take an action to actually determine how this system move forward. And also for your action, you are going to receive some reward. So this is called Markov decision process. It was a widely used model for many sequential decision-making problems. Think of autonomous driving and also many others. So in this case, the goal, since it's sequential decision-making, is actually to maximize cumulative long-term reward. So there's a challenge here because, for example, think about the case where you have an exam tomorrow. You can actually play video game tonight and then fail the exam. In this case, you get like a large immediate reward, but after tomorrow, you're going to be miserable. Or you can study very hard tonight, right? And in this case, you have no immediate reward, but after tomorrow, you can play video games all night. So in this case, what I'm saying here is that there's a trade-off between achieving large immediate reward and achieving large future reward. And this is captured by something called Bellman optimality equation or dynamic programming equation. So this is the most important concept in this sequential decision-making problems. So the context of Markov decision process where the environmental model is known. So these there are many classical results for solving MDP, like value iteration, policy iteration, all these methods. But in reinforcement learning, which deals with the case where the environment is actually unknown or too large to be known, in this case, people need to develop data-driven versions of previous listed iterative algorithms, leading to algorithms like Q-learning, actor critique. So even if you don't know these terminologies, it doesn't matter. So they're all like data-driven iterative algorithms. That's all that matters. Okay, so moving towards multi-agent reinforcement learning, which is also what I work on. This is actually my connection like with ICON, this networks part. And actually the MDP would be the optimization part. And then in multi-agent systems, you have like many agents, and then they live in a shared common environment, but they may have misaligned goals. So in this case, the problem becomes much more challenging because from each agent's viewpoint, the environment becomes non-stationary. The underlying stochastic nature is actually time inhomogeneous Markov chain. And also in this case where the agents are not cooperative, they may have misaligned goals. In this case, it's not clear how to define the solution concepts. There's no global optimality. So you need to look at equilibrium computation and also maybe Nash equilibrium sort of concepts. And finally, there's also sample efficiency and scalability challenge when the number of agents grows. So I also work on the theoretical foundations of this part. So finally, I'm going to actually take a peek into the mathematical foundation of what I do. As I said before, I want to develop foundational understandings. So this is called actually stochastic approximation 101 here. So think about the goal is just to solve an equation, x equal to fx. So the context of single agent reinforcement learning, that will be the Bellman optimality equation. In the context of multi-agent reinforcement learning, think about, let's say, zero-sum games. This will be, let's say, the Nash gap equal to zero equation. And more broadly, in the context of continuous optimization, you can think of this as just the gradient equal to zero equation. So this is the goal here. And then if the operator is, let's say, nicely behaved, let's say contraction mapping, you can solve it using fixed point iteration. This is like, say, 100-year-old result, but not fixed point theorem. But then in the context of reinforcement learning, as I said before, since you don't know the environment, you need to interact with the environment to collect samples and then to perform data-driven iterative algorithms. So which means that the operator is actually unknown to you, but actually you can get a noisy estimate of operator. And then this is called stochastic approximation. If you compare this one with a fixed point iteration, essentially you have a step size here. Because of the noise, you don't want to trust your estimate completely. And also the most important one is that you have this noise. So you may think like this is actually very related to the stochastic gradient descent, celebrated stochastic gradient descent in optimization. It's actually very related, but the differences here are, first of all, this may not be the gradient operator. And also the noise may have very complicated structure. For example, when you're in the multi-agent system, the noise sequence, as I mentioned before, is a time inhomogeneous Markov chain. So that leads to the core part of my research is, as I said before, to understand the convergence behavior of this type of algorithms motivated by applications in reinforcement learning and also learning games. So the first question I'm interested in is like if you have let's say sufficient amount of resource to run this algorithm to infinity, do you have guaranteed convergence to the right thing? And then once this is understood, you may want to understand, let's say, the convergence rate. And the first step maybe is to consider central limit theorem, which can be think of as asymptotic convergence rate. Like in infinity, if you properly scale the iterate, do you have some kind of Gaussian? And then I'm also interested in the real convergence rate. Let's say for a fixed k, if I run the algorithm for fixed number of steps, what can I say about the convergence rate in terms of, let's say, mean square bound or concentration type of bound? And then finally, once we have a clear understanding of existing algorithms, is there a way to develop insights to develop improved algorithm design? That's actually the next step. So that kind of summarizes the core part of my research. And finally, I also want to make a connection of my research to the control part in this icon name. So it's actually through this Lyapunov-based methods. So essentially, the key technical tool I developed to study this type of algorithms is to think of this algorithm as a stochastic and also discrete counterpart of an ordinary differential equation. And since people use Lyapunov-based methods to study the stability of ordinary differential equations, I kind of extend those methods to directly study the convergence rate of this type of stochastic approximation algorithms. And then this is actually the connection to control. I think that's a very short introduction of my research. I teach PhD level topic class on reinforcement learning in last year fall. I may teach it in the future. In case that happens, I will market that class here. And if any students are interested in working on theoretical foundations of reinforcement learning, learning games, please feel free to reach out. Thanks.
A short question? We're gonna save to the network session. All right, thank you. All right, next up. Professor Lab on computer science.
So hi, everyone. I'm Rohan Pleja, assistant professor in computer science. I did my PhD at Georgia Tech in 2023, and then I spent 2 years at MIT Lincoln Laboratory before coming here. And here I'm running the Scale Robotics Lab. So this is the strategies for collaboration, autonomy, learning, and exploration in robotics lab. We focus on a few different things. So the first thing I work on is interactive robot learnings, interactive robot programming. So helping designing approaches so that humans can teach robots new behaviors or correct existing behaviors. So here on the right-hand side, I have a video of me teaching a robot to play, to hit a ping pong ball back across the net. And kind of the research problems in this space that I'm focused on are multitask learning. So teaching a robot to do many things, multimodality learning. So allowing humans different modalities to communicate with a robot and teach it things. And then learning from suboptimal and heterogeneous users. So we shouldn't assume everyone is a roboticist that's interacting with a robot. We might have, people who've never seen a robot before, people who can't physically move it, and other things. I'm interested in explainable robotics. So creating robotic systems that can be understood, traced, and trusted by humans. So a big focus in this space is leveraging like neurosymbolic techniques, tree-based architectures for doing robot reinforcement learning. So on the left-hand side here, I have a tree policy that's controlling the front robot to like stabilize traffic flow for like a figure-8 like driving sequence. I'm interested in multi-robot coordination. So this is developing methods that enable a team of robots to communicate and collaborate in complex environments. So like what the picture on the left here shows is this is like a simulated soccer game of 3v2, like 3 attackers versus 2 defenders, and they're trying to score a goal. And here I have a lot of emphasis on modeling team structure with graphs and coordinating heterogeneous robots. So I'm very interested in thinking about robots that have different capabilities, embodiments, payloads, etc. Human robot teaming is something I've worked on for a little while now. And I think this focuses on allowing humans and machines to better collaborate together. So on the right-hand side, I have human and like an AI working together in Minecraft, because it's a little hard to like deploy humans and robots in the real world just due to safety concerns. And I'm deploying some explainability to help the human understand the robot as it's teaming with it. And here I have some interest in doing like online behavior adaptation, the robots personalizing to humans as they interact with them, information sharing, so like machine translation, and like a human talking to a robot, and thinking about scalability, so multi-human, multi-robot collaboration. And the final thing I focus on is agile robotics, so approaches to make for robots to make rapid decisions under uncertainty. So here I have a tennis playing robot I worked on, where as soon as you hit the ball, it has to make like rapid planning and try to hit the ball back over the net. And here there's an emphasis on high speed robotics, so speeding up robots so they're not very slow and kind of acting or moving as they're reasoning. And then robots in sports. So I have some interest in like different types of sports and like creating robots to solve these like really challenging problems. This semester I'm teaching an imitation learning for robotics course. It's already like 2 weeks in, but I probably will be teaching this course again next year if anyone is interested. And then I'm also looking for students. So if you're, MS, PhD at any level, feel free to reach out if you want to work on some of these interesting problems. Thank you.
Yeah, thanks. Yeah. Let's just save all the questions to the end. Thank you, Professor Palasia. Next up, Professor Ye, I think, from computer science. Oh, so I'm Raymond. So I did my PhD from UIUC just a couple hours away, 2 hours away. So this is my 3rd year at Purdue. And so my research is at the intersection of computer vision and machine learning. So I frequently associate myself with conferences like NeurIPS or CVPR. So the first big block of my research is at designing neural networks. So we're interested in, not just treating neural network as black boxes, but we want to design it for specific properties. So one of the properties that I'm interested in is robustness to geometric transformation. So here I'm showing an image just being downsized, and the feature maps here are being downsized accordingly. So this is actually by design, and we have guarantee on like this will happen exactly for the network that we designed. But in general, if you just feed in a black box neural network, that will not happen. So the way we do this is it's formalized through what's called invariance and equivariance guarantee. So you can think about this as like some push-through operator. So you apply a transformation T on your input X, and we can give you a F that's guaranteed will resulting into a transformation that's on the output, even though when you apply on f of x. So you can kind of push through the transformation through your function f of theta. So a lot of this is actually driven by foundation methods in like signal processing. So a lot of these are signal processing driven design. And that's kind of where what I did my PhD in is at the intersection of like signal processing, image processing, and machine learning. Okay, so the second big block is I do somewhat general machine learning, and the more recent top area that I'm interested in is what's called model immunization. So right now we have a lot of like Gen AI, everything is great, but one of the things is that now artists is somewhat at risk
anyone with a can download the software code and just clone artists kind of style. So one thing that we were thinking about is like, how do we prevent or at least make it a little bit harder for these kind of artist content to be cloned? So what we can do is essentially somewhat like do data poisoning on the model such that if you try to clone a particular artist style, it becomes more difficult. And we call that model immunization. We're kind of thinking viewing as a vaccine. So here we're showing an example where we try to copy Picasso's style, and you can see with and without our method. So the y-axis is performance. So with and without our method, there's a large gap in the performance, and where on the top part you successfully copy back the Picasso style, whereas with our method it doesn't happen. And since we're also besides thinking about just immunizing, another big aspect is about safety on these Gen AI. So one of the things is how can you remove harmful content? So we are also interested in machine learning. Okay, so this is kind of the machine learning side of my research. The other side is computer vision. So computer vision, the first block is computer vision for perception. So in my lab, we're interested in basically any kind of perception task, and specifically we would like to build state-of-the-art systems. So our lab right now have like the facial landmark detection, that's state-of-the-art, that was just published at ICCB. And we also have one of the state-of-the-art in anomaly detection in the online setting. So computer vision is actually a heavily benchmark focus. So basically a lot of the research is how do you get state-of-the-art on these benchmark things. So that's what we specialize in. Oh, and I also work on 3D. So this is just an example of 3D perception, where we try to build a semantic representation that also reflects the underlying 3D structure. So you can have joint understanding of 3D and some semantics. And the final kind of big block is computer vision, but generative. So I also work on these generative models. So this is a inference technique that we can apply to on the existing generative model for videos, and you can see how we improved the kind of video generation quality, and it's better aligned with the text. See how this horse is kind of like running backward, which is not what not expected. Other things, I'm also doing 3D generation, so generating 3D shapes, etc. And finally, this is a project that I really like to talk about. It's called ambiguity generation. This is actually done by an undergrad at Purdue. So what we did is we let AI to design text fonts such that if you read it upright and rotated by 100 degrees, it looks exactly the same. So this is kind of like a cool project that I like to show off because it was like out of the box proposed by an undergrad from Purdue. And I guess that's a good time to say, if you have any questions from
Yeah, thank you, Professor Yep. And last but not least, Professor Tanaka from AAE and UCE.
All right, so it's great to be here. My name is Takashi Tanaka. I joined Purdue actually back in this January as an associate professor with AAE, Erastro, and ECE. So I do research on control and information theory, and I call my group the Network Control Systems Lab. And at a very high level, our group is sort of interested in using information theoretic concepts to make your control system more intelligent, okay? And for a long time, maybe 10 plus years by now, I've been interested in the concept of minimum information control, okay? So probably many of you are very familiar with this feedback control systems concept. Control system is all about information feedback, okay? But the question about how much information how much information feedback do you really need to make your control system functional is very often overlooked, okay? But asking this kind of question is actually sometimes very important. For example, what if your sensor is producing more information that you can process, more information that you can transmit, okay? Do you really need all that information to make your system functional, okay? And asking these kind of questions, we've been developing sort of data compression algorithm for control applications. We developed a method for simultaneous sensor and control algorithm design. And also we even developed the concept of simultaneous perception and motion planning algorithm that allows this kind of mobile robots to navigate itself within this kind of a obstacle field environment with minimum effort of sensing, minimum perception, okay? And let me also talk about this project, which is actually the newest funded project along this line of research. This is about neuromorphic vision. And as you know, vision is a great source of information, right? Think about driving. When you're driving a car, you are exposed to a lot of information, right? But when it comes to the task relevant information, it's not a lot, okay? It's a very small piece of information that is actually very relevant to your driving task. And your brain is doing something very clever to kind of select minimum yet task relevant information from the vast ocean of the incoming information flow. And basically in this project, we are trying to use this interesting camera devices. It's called a neuromorphic camera, also known as event camera, which is sensitive to the only moving portion of the pixels, okay? And we are trying to use this device to extract, task relevant but, critical information from the visual scene. And in fact, event camera itself is not a very intelligent device. And what we are trying to do over here is to develop a new kind of sensors by integrating these event cameras with some sort of optical computing devices. So if you have a research skills that is related to vision and optics, please let us know. Let's collaborate on this line of research. Okay. And this said, we do have other exciting projects. So for example, path integral control, this is a Monte Carlo based motion planning algorithm, path planning algorithm, decision making algorithm that is to be designed to solve a difficult class of stochastic optimal control problems. And people have been using this algorithm for motion planning, but here in one of our projects, we are trying to apply this algorithm to solve a zero-sum game between attacker and the defender over cyber physical systems. And related to the security of control systems, we have also an exciting project about encrypted control system, in which we are trying to apply the concept of cryptography technique to design a secure control systems. Namely, we are trying to use the concept of homomorphic encryption, which is a cryptographic technique to compute something, do some computation over encrypted data without decrypting it. And we are trying to use those techniques to design, let's say, cloud-based control architecture that is secure from the potential bastard. Okay. And if you're interested in these topics, please feel free to reach out to me, and I'm looking forward to working with you. Okay.
Thank you, Professor Tanaka. So as the four professors mentioned, please hang around after the next talk. So around 4:30, you'll have enough time to talk with the professors here. They're looking for students, as you just heard. So reach out and ask detailed questions. So the next session will be our very first ICON seminar this semester. But before I introduce Professor Wachs, I want to introduce you the lineup. Many of you might have already received this list. As Professor Mo just mentioned, we have a diverse lineup this semester. Professors from pretty much all those peer schools and also from industry from DeepMind, Google DeepMind, as well as from Boston Dynamics. They're going to share their experience and their research about control optimization, robotics, AI, and all those big topics here each Friday afternoon. There are just two exceptions. One will be Professor Robert Hui from Harvard, that will be at PGSC. Another one from Professor Scott Mora is also at PGSC. That's right across the street from here, the other building that's right below the Northwestern parking garage. All the other events will be here every Friday afternoon at 3 p.m. All right, now there's mismatch, but so next up, we will introduce our first icon speaker this semester, Professor Juan Wachs, who is an James and Barbara Green Endowed Professor at IE, Industrial Engineering here at Purdue. And also, more importantly, he was serving as the program director at National Science Foundation for the past 3 years. And Professor Wachs has been directing the lab, Intelligent Systems and Assistive Technologies lab here, where he has been developing all those innovations in surgical robots, gesture-based interface, human-robot interaction, AI-powered healthcare systems. I noticed you also have courtesy appointment with IU Medical School, which is very interesting, and he will share more of his insights to us. And without further ado, as well.
Glad, thank you for the invitation. I'm glad to see a lot of faces here of folks that I know. I have gone through long, years of work here at Purdue, and I hope that there is some opportunity to talk about my research, but that's not going to be the focus today. I'm going to talk today about my work as an administrator, bureaucrat, for, I would say this was 4 years ago. I luckily finished my rotation at Purdue at NSF last year when things were still nice and good in Washington, D.C. Since then, I would say that I just left in the right time. Things have changed somehow. So likewise, the things that I'm going to talk about may not be as accurate. Things have changed. And if you ask me, what are the updates? I myself don't know. I keep meeting my colleagues and they ask me and I ask them, they may know even more updates than me about what's going on at NSF. So things have changed in general federal agencies. So what I'm going to tell you now is what has been in the past, and I hope that at some point things go back to what they were. So I'm an old timer here. I have been at Purdue since 2009. I was born in Argentina, born and raised. Do you know who is that guy there playing soccer? Maradona, yes. Now after that was Messi, and also Messi now is retiring. So now it's going to, yes, 2 batches. I did my graduate studies at Ben Gurion University in Israel. And I also have a company that focuses on applying AI techniques to medicine and surgery. Starting a new center soon in the area of AI, medicine, and engineering in Indianapolis. More to come about that, you're going to hear. I serve as a NSF program director in SAIS in the Robust Intelligence Cluster. This was kind of a unique experience given that I'm in engineering, industrial engineering, but given my research work, they realized that I'm going to be more helpful at NSF in computer science than in engineering. So this is where I spend most of my time. In terms of hobbies, I like climbing mountains. This is Kardungla in India. It's the highest motorized road. And someone took me to the top, okay, I didn't climb. You can actually get bikes there and you can go all the way down on your own, which is pretty cool, okay? And it's a road, so it's nice. It was what, 17,000 feet. It's nice, almost 18,000. All right, so as I said, I'm going to talk about my service at NSF. What I'm going to say today is my personal point of view, my personal advice. This is by any means doesn't represent NSF position in this topic. In fact, no one knows what NSF position is right now. I'm not sure that NSF knows, but I'm going to talk about my own experience, okay, for when it comes. I was hired at the NSF as a rotator to deal with the robotics portfolio. And it was kind of an interesting experience. By the way, I'm going to try to stay focused because I tend to start chatting and talking about all kinds of things. But I thought that I was hired to pitch the NRI 4.0 because NRI 3.0 was getting closer to a finish, and I was going to present NRI 4.0. That was my pitch. That was my job talk. And after I was hired, I said, well, hear the news. There's no NRI anymore. That program is dead. But there is a new program called FRR, Foundational Research in Robotics, and it's going to be an interesting program. Was an interesting program, was already starting the second year. It was a cross-directorate program, means involved both the Directorate of Engineering and Computing and Science. And that is the main program funding robotics, but it's not the only program funding robotics. There are other programs like Mind, Machine, and Motor Nexus, M3X, which is a program coming from engineering and CMMI. There are other programs in size like human-centered computing that supports working robotics as well. Not only, okay, it's not the main thing, it's mostly interfaces, and human design, but robotics and human-robot interaction is one of them. And then there are, of course, other programs like Smart Health and Biomedical Research, which they also support working robotics. Again, they support a lot of things, and robotics is only one piece of the portfolio, but they do provide support for that. And there are, in the area of control systems, there is the SD as part of engineering, also supporting robotics, more in the control side of things. So when FRR showed up, people thought or were confusing whether was the new NRI. Now, for some of you folks that are new, you didn't know what NRI is, so you don't care. You know, the NRI is part of the past, but NRI used to be the flagship program in robotics at NSF that would fund projects that were wide, large, collaborative, were projects usually over $1 million, were collaborative projects, large projects, and also for 4 or 5 years. Now, FRR wasn't the same, wasn't the follow-up. FRR was a program that would fund smaller projects with reduced budget, where the philosophy was not so much focused on the integration of robotics or implementation, but more on the fundamental science, as the name indicates. As I said, it deal with partnerships. So NRI originally was a program that involved NASA, Army, NIOSH, USD, USDA, NIH. And what happened is that these programs were pulling out slowly and gradually until the point that the only agency putting money was NSF. With a new program, FRR, a lot of interest came up. People were excited to participate. Up to this day, I think that the only agency right now that is participating is USDA, but I believe that other agencies are going to join eventually when things get calm. And the size of the projects, as I said, a typical project in FRR was below $1 million, was usually 700K, 600, 700K. There was no limit. I mean, in the program description, there was in purpose no limit in terms of the budget, but I'm telling you what was typically funded. As I work in the program, one of my personal objectives was trying to make sure that we can fund more sophisticated research up to the projects above the $1 million. And I'm glad to say that we did support the projects over 1 million that were very good. So what is responsive? And I'm going to talk in present tense because I think the project is still ongoing and objectives are the same. And this is really the only project that I would say, the only program that supports mostly robotics. There are other programs, but this is the one that has been created by definition for robotics. So the two ingredients that you need to have in order to be responsive is to have both the intelligence side and the embodiment side. In other words, you need to have the algorithmic intelligence and the hardware side, okay? The physical representation of the raw hardware the mechanics, the actuation side. And you need to be able, so we use this kind of 3 questions. You know, there is the Hillmeyer catechism in DARPA to decide whether a white paper or a proposal is responsive to the program. So there was a similar a principle at NSF that used these 3 questions to know whether the project was responsive or not, whether there was a robot or not. Of course, there is a question of what is a robot. You know, we look at a robot not as just a robotic arm that repeats the same thing a million times. There is some form of sophistication in terms of the robot. Whether you bring a new capability to robotics, and whether if you take the robot out of the proposal, you still have a proposal. If you still have a proposal after you took out the robot, then the robot is not central to the proposal, and therefore is not responsive. The robot has to be an essential part of it. And you need the 3 pieces to have a proposal that was responsive. So the process was, you write a white paper, a 1-page white paper, you submit that to the robotics program, which is robotics@nsf.org. And again, I cannot right now comment on what is the current practice of this, but this is how we used to manage this. And you know, one of the program directors will reply. Usually there were 2 co-chairs, one from engineering and one from computing. I was the co-chair in computing, and one of us would reply to. Usually I took the role of replying. And the feedback was whether it's responsive or not. And we always try to schedule a meeting with you. If someone from Purdue would send a white paper, I would have a conflict of interest, and I would not be able to open or respond. I would delegate that to someone else. Because even as a program director, my affiliation is Purdue, right? So I have to avoid, by all means, conflicts of interest. Now, the approach was, if we can make it responsive, if there is a twist, if there is something that can make it suitable to the program, we will try to encourage you to do that. We'll have a Zoom meeting, and we'll kind of try to hint, or not hint, help you make it more responsive to the program. If the feedback is no, was really if it's completely out of place. I mean, sometimes we get a feedback that was, look, this is not responsive. Usually something that the person didn't read the program description at all. And once you get the feedback, you would be able to submit a full proposal. Let me say this again. You were allowed and are allowed to submit a full proposal regardless. You don't need this white paper, you don't need this feedback, you don't need any of that. And if the proposal is a proposal that is responsive to the program, no one would check if you submitted a white paper or not. Now, if there was a proposal that was completely out of place, the first question that we as program directors would ask is, who submit that? Did they get a green light to submit this? Because this is completely, look, you work in a proposal, you spend a lot of time, now I'm submitting to NSF as well. Okay, we spend a lot of time in a proposal. No one wants to submit a proposal and get the proposal rejected or not discussed because it's just it's not a good fit. So, of course, the first question that we ask is, did we make a mistake by allowing you or giving you positive feedback for something that shouldn't be? But oftentimes we realize that APIs didn't ask. They went ahead and they submitted the proposal. And then it's fair, game to basically decline. There was another practice that was not a policy, but we try to respect, which is every proposal we try to panel and to discuss. And we try not to triage a proposal. A triage proposal is if a proposal gets reviews that are not better than good, means even if there are 4 reviews and the 4 reviews are good, well, that proposal will not be discussed in the panel. Will be in a category called non-discussed. We try not to to use that practice, but I have to say that there were a few times that had happened. And that happens in some of the programs, okay? So you got the feedback, and based on the feedback, you work on a proposal, a full proposal, and oftentimes when you write the full proposal, you have to go back to the original white paper, because this is where you put your ideas, and also that's the place where we get your feedback. And you submit the paper goes, the proposal goes through the pipelines of NSF, and there is a lot of pipelines and a lot of, bureaucracy until it gets actually to the hands of the program directors. And what we did is we look at the bunch of proposals. Let's say that there are, give or take, 30 proposals in this batch, okay? And when I say a batch, I'm looking at a period of time of 3 months, say, okay? We said, okay, now we need to build a list of the topics that these proposals are dealing with, and we're going to create panels based on those topics. So if we see a lot of proposals on soft robotics is going to be one topic. A lot of proposals on drones, air robotics will be another one, medical robotics, you name it. But we look into the names, usually we came up with a list of 5, 6 topics. So give or take any panel, well, panels usually would have ideally about 10 minimum, 10, 11, 12 proposals for discussions. We came up with a target date for the panels, and then we align the panels or assign the panels to different program directors. For every one of us would be, I don't know, a total of 9, 8 program directors will be responsible of leading one panel. Now, every panel was actually led and co-led by 2 program directors, one from science and one for engineering. Why? We wanted to make clear that the message is that this is a program that combines both engineering and computer science. And the panelists are going to come from both fields. And the program directors making the decisions are going to come from both fields. There's not going to be really any bias, ideally, right? Sometimes the main chair was someone from engineering, sometimes from computing, but always the 2 individuals will have to be present. After that, we identify panelists. Ideally, we identify panelists that do not have an association with any of the universities that submit a proposal to that panel. So let's say that there are 10 proposals, one is from Purdue, which always happens, usually. That means that in that panel, we would try not to invite any panelists from Purdue. So when you volunteer to NSF and you ask to be a panelist and you don't receive an invitation and you wonder whether that happens because you're doing something wrong, it may not have anything to do with you. Basically, if there's a conflict of interest, even that the way to address this conflict of interest is just to ask you to step out of the panel. If it's Zoom, you're going to step out of the Zoom. It was just easier to not invite someone from the same institution. If there was also a proposal from Purdue, I, as a program director, would not be able to sit on that panel. In fact, for program directors, the policies of conflict of interest were even more strict. I cannot lead a panel where there is a proposal from the same institution. Okay, so there is a panel, 2 days, 1.5 days. They are discussion. The first day is discussions about all the proposals and rankings. The second day is further rankings and final decisions, where usually we try to get recommendations for high competitive, low competitive, and sometimes no competitive. And the idea was proposals that are high competitive, try to do our best to support them, okay? And sometimes proposals that were competitive, okay? Now, I have to say that panels that you have no high competitive proposals, and this is because the panelists decide that no proposal is worthwhile. Supporting that or not worthwhile, the category of high competitive. So I say sometimes the toughest people are not actually the program directors, are actually the peer reviewers, right? And I could say, guys, look, there is this amount of budget allocated for the program. We may be able to support one project. But if the scores are bad, It's going to be very difficult from the program directors to support that because there is a scrutiny above us, right? There's a deputy division director and a division director. And they look at the scores, and if the scores are low, there's going to be questions why we want to push that proposal forward. It's going to be very difficult. So when you serve as a panelist, take that into consideration, right? That if you want to see the field advancing forward, you do your part, and unless there is a chance that all the proposals are a disaster. But I have to say that you would be surprised. Proposals are usually really good, and even the ones that receive low competitive scores are good. It's comparative, right? So comparison with others may not be as good, but these are things to take into account. So there are panel recommendations, and what happens afterwards is, let's say that there are 5 panels. Say for the sake of it, typically there was 5, 6 panels. Everything that in every panel, maybe there is one high competitive. It's not always true. Sometimes there are 2 high competitives, sometimes there is no high competitives at all, right? But give or take. So now what we need to do is every directorate has a number of divisions. Now we want to see whether each division is willing to chip some money to support the proposals that score high. So we would working group discussions, WG discussions, the working groups of FRA would meet and discuss all these top proposals. Okay, now if there is any proposal that is interesting and is competitive, maybe not high competitive, but we consider that it's a very nice work and it's worthwhile discussion, that will be something that we're going to bring in the discussions. Usually, if there is a high competitive proposal, also is going to be part of the discussions. It's going to be very rare that a high competitive project is not bring to discussions. And the discussions are basically slides, which we prepare. We prepare 1 slide per proposal, and we pitch this to the rest of the group. Now, the rest of funds are limited, of course, so there's going to be questions. So now the questions are not answered by panelists, but actually for program directors. And they're going to ask questions about the proposal. Well, wait a minute, how they solve this problem? Or do you know if this guy actually has a similar project being funded this year? Because I think that he submitted, oh, wait a minute, what's going on here, right? Could be a lot of things going on. So there are going to be discussions for each project that is bring to discussions. There's going to be discussions for 5-10 minutes, and there's going to be a decision. The decision is either chipping money, right? We're going to put money and we're going to recommend that for funding, or we're going to not move forward with that, or we're going to wait. Okay, those are usually the 3 types of decisions. You always want to be the one that there is a decision to fund. And the reason is, if you wait, the reason is, we may want to wait until the end of the fiscal year to see if there is money remaining. And if there is money remaining, maybe, and this is when you may hear, after several months about the project, they may decide that this is going to be funded. But usually money is not, usually money is missing, right? So there's no extra money. So usually it's not good if a proposal stays in this limbo situation. Sometimes the fiscal year may be over and you may not hear about that proposal. It's still in limbo, still deciding what's going to happen. Still also not a good thing. But anyway, there are decisions. Now, a part of the discussions would be, we want the PI to provide explanations regarding ABCD. Please take notes. The program director will take note. So when the program director contacts you to say, your proposal, if you hear an email, if you get an email from the program director, not an automatic email, that's usually good sign already. And the email will be something like, we are considering this proposal for funding. Please do not take this as a final decision. It's going to be very, how to say, mild. So there's no legal issues, right? NSF is really concerned about legal implications. So they will never tell you that it's funded until you see the money. Right. So, but they're going to say, but you need to submit an explanation about this. There are questions. Please write a 1-page addressing these concerns. If you get this email, I would say 90%, 95% chances it's going to be fine. okay? And you're going to ask maybe to provide a slide, you may ask for IRB, there's a bunch of things. You may ask to reduce the budget. There's also constraints about how much program directors may ask you to reduce the budget. If they ask you to reduce more than 20%, if you need to reduce the budget more than 20%, it's likely that that project is not going to be recommended for fund. In other words, they will not even get to talk to you because it's too much. It's considered a change of the scope, more than 20%. So, but if it's less than 20%, they may ask you to reduce the budget. And then what's going to happen is the program directors are going to pitch the proposals to the division director and the deputy division director to get that blessing. It doesn't usually happen that any of these people are above us more. It's interesting to know the structure. The deputy division director is actually an administrator. He's not a scientist per se. But the deputy director is it's a rotator, as we are, just the chief of the rotators, if you want, right? Was Michael Littman for science. And they will give the blessing usually. They will ask some questions. Look, if the 5 proposals recommended for funding or 10 are all coming from University of Michigan, to give an example, they're going to be questioned. We can say, well, all these proposals are great. Well, they're great, but what happened with diversity? What happened with, it cannot be that no one else is doing good research. So there are all kind of questions that actually you can get from them. And also program directors know that they should seek some form of also diversity in terms of portfolio. Usually these are presented and, blessings are being given. Sometimes questions are being asked. And then we actually contact the PI with the news. I would say those are good news. Now, bad news is when you get a rejection. First of all, we all get rejections. In fact, you're going to get almost all the time rejections. You're going to get very few times awards, okay? And you may get in the beginning a lot of awards, that it's life is going to change, but some awards hopefully you will get. Now you're going to read, first of all, take a few days to calm down to read the reviews. In fact, you may not want to read the reviews the same day, take a few days. And then you're going to read the reviews and the panel summary, and you're going to wonder whether the panelists understood at all what you're trying to do. Okay, so what I say is the reviewers are always right and always wrong. They're always right because this is how the society perceives your research. So even if your research is amazing, if you cannot really explain what you want to do or articulate the idea well enough, you have a problem, regardless of your research. I mean, you need to be able to have that skill. On the other side, they're always wrong in the sense that they will never understand your research as good as you do, or how important it is as good as you do. So they're both sides, and you need to understand that as well, right? You need also to know how to read your feedback. There are a lot of messages. The message, you may get a low competitive or competitive, but the reviewers are going to tell you something like, we want to see this again. Well, they're not going to see this again because the panels change all the time, right? But the message is, you should keep trying to submit this because this has a lot of value. Or they may say you something else. They may tell you something else that the message is basically go with this somewhere else, right? So you need to take your time to read the feedback and sometimes talk to your colleagues about the feedback. Definitely talk with your co-PIs, to see how they interpret the feedback. I would say always try to talk to the program director. Again, this is for normal times. Now we are not in normal times. I don't know if anyone is going to talk to you. I don't know what programs are around. I don't know who are the program directors that are around. But in normal times, what the practice that you would like to have, and I would say this is for every program. Some programs may share more information, NSF will share a fair amount of information, NIH good, DARPA will bring the lawyers and will not share any information, but they will talk to you. So I would say, but talk to the program directors because they will remember more or less what happened. and they may give you an indication whether it's worthwhile. What you actually want to know is whether it's worthwhile resubmitting. You don't want to use the expression resubmit, but you want to say, look, if the idea is compelling, we can actually work on all these problems and try to ship it again to NSF. Is this something that you think is a good idea or not? And see how they respond, right? That's the best indication for you whether it's the response. As I said, the scores are, if you get non-competitive or non-discussed, there's no point taking that forward, go with something else. Low competitive depends on the project. It's also, I would say, not very encouraging. But you may decide to work on the proposal and resubmit. And if you get a competitive, high competitive, definitely keep going. If you get a they will tell you that you cannot submit the same proposal, blah, blah, blah. I tell you, if you have a high competitive and they tell you that you need to change very few things, just change very few things and submit. If the idea is good, keep the idea. And if it's competitive, probably it's a really good proposal as well. Okay, so, keep going with that. Right. Okay, getting money from NSF and any other agency is difficult. So if you go on the regular track to get funding, that's the right way to go, I would say, right? But it's going to take some time. Sometimes it may take a few years, depending on your luck. There's a number of things that you can do to be known, and that helps. It's not formally, no one is going to tell you that formally this has an effect, but connections, contacts, personal interaction has an effect, I can tell you. So show your face. I'll become a reviewer, volunteer. I would say typically volunteer, typically twice a year, maybe 3 times a year as a panelist. Definitely twice a year you can do that. Once you're in their databases, they will keep calling you. Try to go, try to come, they will remember. People will remember you. That helps. If there are workshops for new faculty, for all of you, the ones of you that are going to be new faculty or are new faculty, there are usually workshops at NSF called future PIs, candidate PIs. I don't even remember the name of that. But there is a workshop usually at NSF. So usually NSF meetings, NSF PI meetings will have a workshop called candidate PIs, or, these are actually workshops for people that don't have funding, or aspirate PIs, but people that want to get funding. Go show off your face, attend, you can only learn, right? There is a lot of small things that you can do. It's not much money. This is not going to be enough to pay your summer salary. It's not going to be enough to pay your students. It's not going to be enough to pay anything. So why? It's important because in the moment that you are in the database of NSF, you can actually write in your proposals in the section of prior support, you actually can write those projects, even if what you get is $10,000 or $5,000, barely for equipment or supplies. But you are inside the system as an awardee. So what are things that you can do? You can offer a workshop, organize a workshop in one of the conferences, organize a workshop, a conference, a symposium, a special session, and talk to a program director with a program related to that area and say, this is what I plan to do in IROS, ICRA, whatever. Would you guys be interested in supporting this? This will support students, travel, for example. Again, it's a lot of work for you. It's not going to give you exactly what you need now, but a lot of the work that you do now, it's not immediate reward or compensation. You need to look at the long run. Okay, and in the long game, this is worthwhile. So basically engage with NSF, right, in all kind of ways. Another example is recently, as yesterday, I believe, there was a workshop for AI, resources in computing, cloud computing, FAIR, F-A-I-R-R. Okay, so if you submit that, you don't get money. They give you resources. And again, a lot of people will be, why should spend time working on this if I don't get mad? Well, the answer is, first of all, proposals are much shorter, they are less competitive, and again, it's about your name being in the databases. Okay, it's just starting slow. If this is the best that you can do, in the beginning, why not? Okay, what makes a good proposal? Must be responsive. That is, now a proposal that is responsive is not necessarily a good proposal, but it's a proposal that has chances. A proposal that is not responsive doesn't have any chances. So it has to be responsive to the program. That's the very basic. Second, it has to be something that is exciting. Now, sometimes people talk about career, yes, career, no career. I'm going to tell you it doesn't matter career or no career. Any proposal has to be exciting. And in that sense, there's no differences. It has to be something that you have a story to tell, something that people will engage, something that is so cool that you want to get the panelists fighting for it. In the moment that you have two people supporting that idea because they got excited, not because they know you necessarily, but because they got excited, they're going to fight for it. The worst thing that can happen to a proposal is that no one cares about it. I mean, it's not a bad proposal. A proposal can technically be perfect. But if no one cares about the proposal because it's not telling an interesting story, no one is going to fight for it. And you need people to fight for it. Because this is what happened in the panel. People are going to fight. Okay. Once you get an exciting idea, you can start working on the solution. Don't try to find an idea from a solution. In other words, some people say, okay, what is going to be my first proposal? Well, I'm a person that works always in natural interfaces. So I'm going to Chester-based interfaces. So I'm going to come up with a project that is about Chester interface. That's the wrong way to go. Because yes, you are the right person to write that proposal, but the proposal may not be interesting. Start with a proposal that is exciting, interesting, then ask the question, how you solve that problem? Maybe you cannot solve that problem alone, maybe you need help. Maybe you can, maybe you need to think about how to do it. But it has to be exciting. If it's not exciting, there is no point. Okay? Talk to people, talk to colleagues, family, friends. People will tell you, write a proposal, give your career to your colleagues. Okay, I'm going to tell you, no one is going to give it that. No one is going to read your 15 pages of your proposal with the care that you need. They may not tell you that because they don't want to be that person that tells you, I'm not going to read your proposal, but I'm going to tell you. What you need is not someone that reads your 15 pages and tell you it's great or not. What you need is a person that can look at your summary page, okay, and can tell you, this is exciting. You are going to be in charge of the 15 pages. You know who is going to read the 15 pages? Maybe your co-investigator. If it's a career, there is no co-investigator, well, you will read that several times, okay? Maybe someone may read that, maybe your friends will, but the thing is, it's better to ask little and to get that little done than to ask too much and get nothing. Okay, so if you send a one page to your colleagues, five of your, I cannot imagine that people will not read a one page. And you know what? It's really what you need. Why? Because what you want to know from your proposal, if the idea is exciting or not. You don't want to know if it's technically correct or not, because this is why you are there. And this is why you have your job here. People believe that you know what you're doing. So what you want to know if the idea is cool. And you can tell that from the summary page. The reviewers can tell that from the summary page. So you have to be able to do that. Be excited about what you want to do. Don't do that because your boss told you to do that or because you are supposed to do it. Do it when you feel that it's something that you're excited and enthusiastic about. And just, again, think about something that you really would like to do if you get the money. Because, the worst thing that can happen to you is actually get the money and then you're stuck 5 years or 3 years to do actually work that you don't want to do. Because you're not going to do a good job. If you don't want to do it, doesn't matter if you have the money or not, you are just not going to do a good job. So it's an act of love, be excited about that. The proposal has to be coherent, like a story, compact and concise. It needs to make sense. You know, if you want to say what you need to say in 10 pages, well, your proposal should be 10 pages long, not 15. I mean, so, but you need to work around because you have 15 pages, but you need to say what you need to say in the right amount of pages. Don't be repetitive, be concise, say what you have to say, don't waste time, don't waste space, just be coherent. All right, I just want to say a couple of words for HRI. This may not be relevant anymore. FRR was a program that when it started, the area of human-robot interaction wasn't very significant. This is something that has changed. One of the program directors now in FRR is a person that is coming from the human-robot interaction side. So the one thing that I would say is that FRR, if you have a question whether FRR is going to support research in marine robotics or human-like robots or humanoid robots or insect robots or biospace robotics, the answer is that's not the question. FRR can support any type of research as long as the research is innovative and has these three key components. There is not an area that is preferred to a different area, okay? If you are bringing innovation and you're making the case, any area is actually welcome. All right, that's it. Thank you.
Thank you. Any questions from both from mostly faculty members? Or we can save a question for, oh, yeah. All right.
So I just want to say that NSF does exist. I got an award a couple weeks ago, so like. I wasn't trying to brag. I was just saying like you should still write proposals and they want us to submit proposals. You shouldn't try and talk to the program managers. They're trying to respond. They're doing the job of like 5 people. So they're sometimes slower than normal to respond, but they do exist and they want proposals. It was actually crazy quick because they had money to spend. So it was like we submitted in early June and we got it in like officially in August. Which program? CDSG, so it's a program with my co-advisor.
What about this? I will leave the network session open, so faculty can mingle with Professor Wachs, students can mingle with the newly affiliated icons faculty members, and enjoy the food and water that we still have, and we'll come back to the new semester, and I'll see you next Friday. Thank you.